Hello everyone, this is part 5 of Econometrics where we're going to go over a lot of math. So in the previous video, we went over the OLS assumptions that make our OLS estimators to be unbiased and consistent. We focus mainly on intuition. We're going to tie some loose ends in this video. Specifically, we'll go over proofs to back up some of the results using math. I first want to talk about this equation for beta 1 hat. I already showed you that this equation is equal to these two equations. And now I'll show using math why that is the case. Okay, so then starting from this equation, we're first going to note that these set of equations are true. You can pause the video and take a look, but yes, these are correct. Now, using these equations, we know that beta 1 hat can be written in this form. So note that this part is exactly same as the equation on top if you bring in the xi's into the parentheses. Now, if you look at these two terms in the numerator, they're the same if you sum up the terms from I equals 1 through n. And you can see that by looking at these two terms, since both of them are equal to n times y bar times x bar. Also, note that one of the terms in the numerator in the equation at the bottom is negative. So we're basically just adding 0 into the numerator. And it's the same in the denominator too. We're simply adding 0 here because sum of each term is equal to one another. The bottom line is that the equation at the very top is equal to the equation at the bottom. So then now from this equation, we can get to all these three equations. The one in the middle is what we began with, so that's an obvious one. And you can spend a little bit of time to see that you can also get to the two equations at the bottom. So all four equations that you see on this page are all equal. Okay, now we're going to do another exercise, which is about our third assumption. In video part number 4, I said that since expected value of ui given xi is 0 for any value of xi, expected value of ui does not depend on xi. So one of the implications of this assumption is that there is no covariance between ui and xi. And also, if you remember, by using the fact that covariance between ui and xi equals 0, and also by using LIE, we arrived at these two equations. So all of this is something that you saw already in one of the previous videos. Now in this video, I'm going to show using math how our third assumption implies 0 covariance between ui and xi, because in video part number 4, I only use intuition. So we start from our third assumption. First, by using LIE, we're going to get the result that says that expected value of ui equals 0. And then we're going to note that by definition of covariance, we have this equation. Since expected value of ui equals 0, we get this equation. Now note the right-hand side. The term on the right-hand side is equal to this term by LIE. And this term on the right-hand side equals this term. So what happened here is that since we're conditioning on xi becomes non-random, and so we can take it out from the first expectation. Now by our third assumption, expected value of ui given xi equals 0, so that this entire term simply equals 0. Therefore, I have now shown that our third assumption implies the three equations here at the bottom. Now for the next proof, I want to come back to our third assumption. We know that this assumption implies these two equations, and if we plug in for ui, we're going to get these two equations at the bottom. And in the previous video, I said that if we solve for beta 0 and beta 1, we get these two equations for beta 0 and beta 1. I'm now going to show you in detail how we arrive at these two solutions. I'm first going to solve for beta 0 by using this equation. And note that this equation becomes this equation if we bring in the expectations. Now beta 0 and beta 1 are constants, so if we solve for beta 0 can be expressed with this equation. Now we're going to solve for beta 1 using this equation. Here, I'm going to plug in for beta 0 that we already solved for, so we get this equation. And from here, if you do a little bit of algebra, you're going to end up with this equation for beta 1. So I skipped a couple of steps, but it's pretty straightforward. From here, you can see that the numerator is covariance of y and x by definition, and the denominator is variance of x by definition. In the end, we get the equation that says beta 1 equals covariance between y and x divided by variance of x. So the main message here is that our third assumption implies that beta 0 and beta 1 are given by these equations. which also happen to be the results that we get by applying the OLS method on the population data. So these are all the proofs that I wanted to go over before making the next video. And in the next video, we'll go over the proofs for unbiasedness and consistency of our estimators.